Welcome to Two Projects. In this video, we are going to see smart internet probing, scanning using adaptive machine learning. Introduction. In an era where network security is of paramount importance, internet scanning serves as a crucial tool for comprehending network topologies and identifying potential vulnerabilities. However, the traditional scanning methods often suffer from resource wastage caused by excessive traffic. To tackle this challenge, we present an innovative machine learning framework that intelligently predicts host responses to specific port probes. By harnessing geolocation and autonomous system data, our approach streamlines scanning processes, minimizing unnecessary probes and significantly improving scanning efficiency. As the adoption of IPv6 grows, our evaluation demonstrates substantial bandwidth savings and heightened true positive rates, marking a pivotal advancement in smarter and more effective internet scanning practices. Objective of the project. The goal of this project is to create a machine learning based solution that enhances internet scanning by anticipating the presence of services on servers without sending pointless probes. The project aims to find the best method for classifying active and inactive ports by training and analyzing various algorithms on the census dataset. The ultimate goal of the study is to considerably reduce network bandwidth usage and resource utilization during internet scanning. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDL of Python 3.7 version. These are the algorithms used in this project. The first algorithm is logistic regression algorithm. It is a linear classification model baseline for port classification due to simplicity and interpretability. The second algorithm used is support vector machine algorithm. It is effective for binary classification. It separates data points using hyperplanes, useful for distinguishing active and inactive ports. The third algorithm is decision tree algorithm. It is a tree-like model for classification, captures port responses dependencies, improving classification accuracy. The next algorithm used is random forest algorithm. It is an ensemble method with multiple decision trees. It handles high-dimensional data, reduces overfitting, aiding port classification. The next algorithm is gradient boosting algorithm. It is an ensemble method building strong learners, enhances prediction accuracy, detects active ports with higher true positive rates. The next algorithm is XGBoost algorithm. XGBoost is an advanced gradient boosting algorithm known for its high performance and accuracy. It efficiently handles complex datasets, making precise predictions and resulting in significant bandwidth savings during internet scanning. The last algorithm used is deep learning algorithm. Neural networks for complex feature representations captures intricate relationships among port responses, making internet probing smarter and efficient. To execute this project, we have designed the following modules. The first module is upload intern port scan dataset. Using this module, we will upload dataset to application and then display types of ports found in dataset. The second module is dataset preprocessing. Dataset contains non-numeric and numeric data, and machine learning algorithms only accept numeric data. So by using this module, we will encode non-numeric data into numeric and then split dataset into train and test, where application uses 80% of the data for training and 20% for testing. The third module is run logistic regression algorithm. Using this module, we will train logistic regression by using 80% of the data and then apply regression model on 20% data to calculate true positive rate value. The higher the true positive rate, the better is the algorithm. Similarly, in the next modules, we will train support vector machine algorithm, decision trees, random forest, gradient boosting, XGBoost and deep learning algorithms. The last module is comparison graph. Using this module, we will plot true positive rate graph of all algorithms. Execution of the project. To execute this project, first we have to open the code folder. This is the dataset folder in which I have internet stand data. This is the model folder in which I have a few text documents which contains algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. These are Python main code files, and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Internet Port Scan Dataset button. A dialog box opens. Select the dataset and click on Open. So in this graph, on x-axis I have ports and on y-axis I have count of each port in dataset. Close this graph, and in the text area we can see a confirmation that the dataset is loaded, and the dataset, these are the top 5 rows of the dataset, and there are numeric as well as non-numeric values in the data, and there are 42 columns in the data. Now click on Data Preprocessing button. So after preprocessing, all the non-numeric values are converted into numeric, and total records found in dataset are 1,93,315, and there are 40 columns, and a few irrelevant columns are removed from the data, and now we have 39 features. So the dataset is split into train and test sets in the ratio of 80:20. Now train set includes 1,54,652 records, and test set includes 38,663 records. Now click on Run Logistic Regression Algorithm button. So in this confusion matrix, on x-axis I have predicted labels, and on y-axis I have true labels, and we can see all labels are predicted only in one class. So we can say the performance of this model is not satisfactory. Close this graph, and in the text area we can see the true positive rate of logistic regression. Now click on Run Support Vector Machine Algorithm button. So again, all labels are predicted only in one class, which indicates that the model is not doing well in this particular project. Close this graph, and this is the true positive rate of support vector machine algorithm. Now click on Run Decision Tree Algorithm button. So we can see improvement in this model when compared to the previous models, and these diagonal boxes values are the true positives and rest are misclassifications. Close this graph, and this is the true positive rate of decision tree algorithm. Now click on Run Random Forest Algorithm button. So this is the confusion matrix of random forest algorithm. Close this graph, and this is the true positive rate of random forest algorithm. So we can say random forest is also performing well when compared to support vector machine and logistic regression. Now click on Run Gradient Boosting Algorithm button. So this is the confusion matrix of gradient boosting, and this is the true positive rate of gradient boosting. We can say till now gradient boosting is doing well when compared to the other models. Now click on Run XGBoost Algorithm button. So this is the confusion matrix, and this is the true positive rate of XGBoost, and we can say that XGBoost has outperformed other models till now. Now run Deep Learning Algorithm button. So from confusion matrix graph we can say deep learning model's performance is not satisfactory in this particular project. Close this graph, and this is the true positive rate of deep learning model. Now click on Comparison Graph button. So In this graph, on x-axis I have algorithm names and on y-axis I have true positive rates, and in this graph we are comparing the true positive rates of all the algorithms, and we can see XGBoost is performing well when compared to other models, and the least performing model is deep learning. Close this graph, and the conclusion here is we present an innovative method for internet scanning in this project that makes use of adaptive machine learning techniques. We demonstrate the potency of our method for predicting the availability of services on servers by examining the census dataset and using a variety of algorithms. With the highest true positive rate of the tested algorithms, XGBoost stand out as the most promising. According to our project, intelligent port prediction prior to scanning can result in significant network bandwidth and resource savings, improving the effectiveness and cost effectiveness of internet scanning.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.